So on the test, looking at 45, 45, 90 triangles. Again, you don't have to memorize these ratios and these side lengths, but it helps if you can. If you can't, though, you could go out on a sheet of paper and say, okay, if it's 45, 45, 90, I know these two sides have to be congruent. So let's let each side equal 1. Pythagorean theorem says, if I want to find this, leg squared plus leg squared equals hypotenuse squared. Well, 1 squared plus 1 squared is 2 equals c squared, so c ends up being the square root of 2. If I then draw a 45, 45, 90 triangle where the side lengths are 2, well, 2 squared plus 2 squared equals hypotenuse squared. 4 plus 4 is 8 equals the hypotenuse squared. So the hypotenuse is the square root of 8, but then that has a perfect square in it. Square root of 4 times the square root of 2, which means it's 2 times the square root of 2. And I can build some triangles like this to finally start to notice that the hypotenuse is the leg times the square root of 2. Once I have that, I can look at a problem like the second one and say, well, that is equal to the leg times the square root of 2. The way I solve for a is to divide both sides by the square root of 2. So I end up with 40 over the square root of 2, and then the units on this is feet. These two are congruent to each other, so b is also 40 over the square root of 2, and then feet. If you rationalize the denominator, which was not required, this was 20 square roots of 2 feet. When I'm looking at a square, I know that the sides of a square are congruent to each other, so when I divide the square this way to look for this diagonal, I know that this is a 45, 45, 90 right triangle. The way I find the area of the square is to take the side and square it. So x squared is 225. Square rooting both sides, x is then 15. The diagonal is the side length times the square root of 2, so it's 15 square roots of 2, and then it's meters for my units.